Your grade 11 trig has got three main parts. First, start with your reductions up to the general solution. That's what I call part 1. Then part 2 are the trigonometric graphs. Okay? And remember, the new aspect on trigonometric graphs in grade 11 is mainly the change in period and horizontal shift. Those are the two aspects. So that's part 2, that is the trigonometric graphs. Then part 3 now is the area, sine, and cosine rule. So this year, we are teaching it in term 3 after having finished all the key aspects on trig, right? This part 3, that is area, sine, and cosine rule, is mainly based on calculation of the lengths of triangles that are not right angle. Up to this stage, you have determined the lengths of sides and angles of triangles that are right angled. Okay, so you were taught that last year, use trig ratios. That's what they're all about. Solving the lengths of sides and angles of right angled triangles. Now, you need to know that it's also possible that you may get a triangle which is not right angled, and you may be asked to determine the area of that triangle. You may be asked to determine the length of one of the three sides of that triangle. Sometimes you may be asked to determine the size of an angle of that specific triangle. Now, if the triangle is not right angled, things become more complex. Up to this stage, you have never encountered a question where you are asked to determine the length of a side of a triangle or an interior angle of a triangle which is not right angled. Okay, so the area rule is another way of calculating the area of a triangle. At this stage, you have used half base times height to calculate the area of a triangle. Now, there's a new formula which has got some trigonometry which is called the area rule. We also talk about the sine rule. We also talk about the cosine rule. Now, this topic is very important up to metric. The last question, when you write metric, the last question on trigonometry is going to be on application of this topic. So it always comes in any metric paper. So it's a very important topic, right? The aspects are taught in grade 11 to prepare you for your grade 12. So with the area rule, the basic idea is you'll be given two sides. Okay, you'll be given the length of two sides and the size of an angle between them. So your area rule, it is a formula which is used to determine the area of a triangle which is not right angled. Okay? So far you have used half base times height because that was for a right angle triangle. It also worked for triangles that were not right angled, but you had to be given a perpendicular height. Now you can now calculate, after having done trigonometry that is in grade 10 and in grade 11, it is now possible to determine the area of a triangle which is not right angled using what's called the area rule. But now, there is one property which is very important for you to use the area rule. You must be given two sides. Okay? So, out of the three sides, two sides must be given. Also, the angle between those two sides must be given. So you must have two sides that converge to form an angle, and then the angle between those two lengths or two sides must also be provided. If that's the case, then you can now use the area rule to determine the area of that triangle. So there are three scenarios. Okay, let's say you're given a triangle ABC. I hope you can remember that we can name the lengths of the triangle using the small letters. So vertex A is a capital letter. The side opposite vertex A, we can name it as a small a. Right? Then the side opposite angle B of vertex B, we can name it as a small b. And also the side opposite angle C or vertex C, we can name it using a small c. So we can use the lowercase letters of the vertices to name those what? Those sides, or the sides that are opposite those vertices. Alright? Now once you are aware of that, then the area of any triangle ABC, you can write it as half AB sine C. So if you are given A and you are given B, it means you are supposed to be given angle C. Okay? So you'll be given AC, you'll be given BC, and the angle between them. You can also be given angle B. If you are given angle B, it means BC must be provided and AB must be provided, and the area will be half AC sine B. Okay? So always this angle here, which you put in your calculator as part of the trick, it has to be an angle which is given. Then the two sides that form that angle must also be provided. So, if you are given angle A, it means that you must be given AB as your length and AC as your length, so that the area will be half BC sine A. It's very straightforward. It's very easy to use. All right. Is there anybody else got a question? I got one to ask. All right. Now, the proof of area rule is examinable. So I'm going to write here, please write in your book as well, examinable. What this means is, you can get a question in a maths paper saying, prove that the area of a triangle ABC is half AB sine C, or is half AC sine B, or is equal to BC sine A, half BC sine A. You can get a question like that. So whenever you come to your test or examination, make sure you know your proof of area rule. One of the three may be tested. Either the area rule, I will talk about the sine rule just now, or you can also get the cosine rule. Right, let's talk about the proof now. Now with the proof, we combine our knowledge of trigonometric ratios from grade 10 and also the area of a triangle, half base times height. So, first you must be given a triangle ABC. Now, then you must construct a perpendicular, okay? A perpendicular to what? To BC. In that case, BC has to be the base. Now, it's going to depend on which side you choose to be the base. In this case here, the base is BC. Therefore, you can draw a line which is perpendicular to the base BC. It has to be drawn from vertex A. Okay? So you draw a perpendicular from vertex A to base BC. Once you do that, you create three triangles. Okay? Of the three triangles, first we need to know what is the area of triangle ABC using the knowledge you already know, which is half base times height. Okay? So if AD is the height, if I want to calculate the area of triangle ABC, if I use half base times height, it's going to be half times A times H. So we end up getting that equation. So the area of triangle ABC, based on this diagram here, if BC is the base, it's going to be half A times H. Then we introduce trigonometric ratios. But the way we introduce it, we try to determine a formula for calculating H. So we want to eliminate this H here in equation 1. Okay? The only way we can eliminate it is to use triangle ACD. Because in triangle ACD, we can apply our knowledge of trigonometric ratios because the angle C is part of triangle ACD. Therefore, if we use trigonometric ratios, this will be the opposite side, and then AC is going to be the adjacent side. So we can end up having sine C is equal to H over B. And then you get this from your grade 10. Okay? Then you make H the subject, you get H equal to B sine C. You then substitute that B sine C where there is H here, and you come up with the formula half AB sine C. Now, you have to be very, very careful if you are doing the proof. you must always look at the given angle. The given angle will give you a clue as to which side is going to be the base. Okay, so this is the scenario. Make sure you are familiar with this proof. Okay, any question? So, okay, if you don't have a question, then allow me to carry on quickly to an example. Right, so here we have got a few examples. Okay, the first one, that one there, we are given triangle BCD. Okay, so always it's better to name your sides using the lowercase letters. So our vertex B is going to be opposite CD, therefore we can call that lowercase b. Our vertex C is opposite BD, therefore we can call BD lowercase c. And then BC is opposite D, therefore this side we can call it lowercase d. Once you do that, then you identify your given angle. Our angle is B. Therefore, if we are to calculate the area of triangle BCD, we must know the length of BC, we must know the length of BD. Fortunately, because this is a very simple example, we are given the length of BD, the length of BC is given, so it's very straightforward. So our formula for the area of triangle BCD is going to be half CD sine B, because the angle B is given. Hence, the two letters which I put here must exclude the lowercase for the given angle. So it will be half CD sine B. And then you do your substitution, use your calculator, you simplify. Now your answer must be in square units. Your answer must be in square units because it's area. Okay? Answer must be in square units because that's area. Okay, so this is a very simple example. Actually, it's the basic example on the use of the area rule. Now, it's not always that you may be given an angle. Okay? You may not be given the size of an angle which you want, so you might have to use your knowledge of geometry of triangles in order to determine the size of an angle. So, in example 2, we have got a case where we want to calculate the area of triangle DEF. That I'll give you an opportunity. Okay? The basic idea is that the ratio of the sine of an angle can be divided by the side which is opposite that angle. Like, for example, we have got an angle here, which is angle B. So, if I write this ratio, sine of angle B divided by the side opposite, is going to be equal to small b. So that ratio, sine B divided by B, where the small b is the length, is also equivalent to sine A over the side opposite angle A, and it's also equal to the sine of angle C over the side which is opposite angle C. Okay? So the three ratios are equal. So sine B over sine over B is equal to sine A over side A, and then sine C divided by side C. They are all equal, those ratios. Now, where does this come from? Well, the easiest proof is to use the area rule. But when you use area rule, you just divide by half ABC. Now, before I come to the proof, it's important for you to know that in most cases, you don't need all three ratios. You only need what? Two of them. So, for example, if you want to calculate this small b here, you have to be given the size of angle B. You need, say, angle A, and then the length which is opposite angle A. That's one scenario. You can also have sine B over B being equal to sine C over what? Over C. Now, it's going to depend on the question you have. But always, you need a pair of these ratios, okay, for you to be able to calculate an angle and for you to be able to calculate the length of a side. Now, with the sine rule, the good thing about it is that you can use it to calculate an interior angle. Now, if you want to calculate an interior angle, it means you must be given two sides and one angle. But that angle which you are given, the side opposite it must be provided. You can also use it to calculate the length of a side, whereby two angles must be given and one side which is opposite one of the two angles. So those are the scenarios. So with the sine rule, you can write it in two ways. Okay, in my case, I used to prefer to write it like this, whereby I'll put the lengths on top and the sine ratios in the denominator. But I changed a little bit. I'm now writing it like that. Now, it's your choice. There is no specific rule which will say put the angles on top and the sides at the bottom. It's your choice. Okay? So you can write like this or like that. Okay? Whichever way you decide there, I'm not going to prescribe and say follow this way. It's your choice. Now, if you want to prove the area rule, first you need to remember that your formula for area rule, it will be half BC sine A, half AC sine B, and half AB sine C. Then you divide those right-hand sides by half ABC. If you do that, you come to these three ratios, okay, which you can flip as well and start with the letters, or rather the length of sides as your numerator and the sine ratios as your denominator. So this proof is very straightforward. Okay, you just have to remember the division here, which takes place here by half ABC. That's all. Okay, the only thing now is to apply that to answer questions. Okay, so we'll carry on tomorrow, but I need to give you maybe homework for today.